Do we need to plug in the...
I pressed enter.
Do we need to plug in the battery?
Not yet.
Okay.
And so now it's going to bring you this whole menu. This is your main menu. And A stands for adjust, T stands for test, H is header, S is station, C is component, M is measure, R is recall. Those are the only ones you're going to use right now. When you actually pull the data off, you're going to use the F and D, which is file and dump. But that will come at the end of class. So right now, just go to test.
Where is the F?
Which is T.
Test.
And then enter. And all 3 of these tests need to be run every time you start the box.
All 3 tests. Okay.
The last one takes 10 minutes about.
What is it testing?
It's all the circuits, components, electronics.
Okay.
Once you get it started, can you just walk away? No, this is definitely not a walk-away system.
So what do I do?
Okay. So if you push it over to yes and hit go, enter, go. This one will take pretty quick. The next one's pretty quick too, and then it's the last one.
So auto calibration.
Yeah. So notice here that it also provides the voltage of this battery. And you're going to want to take a note of that every time you take a measurement.
12 point.
Circuit components, making sure that it's all happy. If a test ever fails, you have to turn the box off and restart the entire box. And every time you restart, you have to run all 3 tests. Every time you change anything in the adjust menu, you have to run the first 2 tests.
Okay.
Does it automatically run just all 3?
So I should do the second one right now.
Sorry,
Cali
that's
check.
not hard.
It's done. And then the system test.
Yeah, and this one's the one that takes a while.
Okay.
And so this is the one that you only run whenever you start the box.
So you do the first 2 every time you...
So
you do the first 2 every time you change the calibration.
Anything in the adjust menu.
Okay.
And everything you do is always in the adjust menu.
Cool.
So if you're taking multiple tests but not changing anything in the adjust menu,
You
do you
don't
need
need
to run
to.
tests?
No.
Okay.
Just stand right there. I'll take
So
the
what
recorder.
again is this directly measuring?
Maybe not.
We're measuring
Yeah,
the
lean over a little.
secondary magnetic
There you go,
field.
perfect.
So actually the decay of the secondary magnetic field.
So that's the one that's being induced by primary electric
Is
field.
this considered a wire loop?
Primary magnetic
Secondary
primary
electric
magnetic field does that.
Okay, you can go hit the main menu, which is the M period M. So then go to the header.
Header. H is header. Okay.
And in here, if you have multiple operators, you can keep track by a number. In general, I always just leave it to 1, and I just keep track on paper who did what.
Okay.
Change the date. Notice that the format is day, month, year.
Okay, so today is the
29th.
29th, and everything else is correct.
29, not
Oh,
29.
thank you.
You have to move off to move back
No,
on.
go. Okay. 29. Okay.
Yeah, and then your loop size is 25 by 25.
25. Go away. No.
It's a pretty touchy little.
How do I go
I would just hit
delete?
25 now.
Oh, okay.
Yeah, there's no delete. You just overwrite. I would change the
Hold on. This
amperage
is a struggle.
to 2 amps.
Amperage to 2 amp.
Yeah, and then turn off time to like 3 microseconds.
I'm not there yet. 2
It's
amps.
the current that's important.
3 microseconds.
Yeah.
That's right.
Is this on video?
Current's important,
Yeah.
not the voltage,
Cool.
right?
The voltage is automatically regulated by the transmitter.
No, but I mean, like, as far as the readings we get as a result of it, I mean, does the voltage even matter? Or is
Yeah,
it
you're
just
what that's measuring is like picovolts per ammeter squared.
And it's
or
on
something.
TEM47.
Oh, okay.
Yeah.
So it's not measuring current.
Well, I mean,
We should leave a
V
comment,
equals
go
IR,
team.
right?
Yeah.
So it is.
What?
Exactly.
Okay.
We should leave a comment, go team, you know?
So hold
I'm not typing that,
Oh, okay.
but we can mentally picture it.
Current
Electric
in that guy.
Okay, so
electric,
what do I do
electric
next?
current.
I thought you were running
ground.
We are in the so the transmitter loop has the main current in it,
Okay.
and so that's where we just set the 2 amps. We're saying that we're going to set this to 2 amps, the transmitter, and so it's pulsing the current in a bimodal waveform that's 50% duty cycle, meaning that you're going to have from time 0, it's going to go on, for a certain time period, to off for the same time period, to negative for the same time period, back to 0 for the same time period. And so whenever it's 0, that's when you're actually recording your data.
So, okay, so it goes 0, positive, 0, negative, or 0, positive?
There's going to be a 0 between
Okay.
positive and negatives. Yep. And so the decay happens right there at the shutoffs.
Decay happens at shut off.
So what we're doing is we're producing an electric current through that wire. Produces a magnetic field.
That's the primary magnetic field.
Right.
Primary electric and primary magnetic.
Right. And
What
that
did he show you?
magnetic field
Secondary
There's a
electric.
figure.
Primary magnetic
See?
field induces a secondary electric field.
right? And then the
Okay.
secondary electric field produces a secondary magnetic field, which
Yes.
we are measuring.
You're measuring the decay of the secondary magnetic field.
Measuring decay.
Does that pick up the primary?
No, because of the way that they measure time 0 for that.
Okay.
So
Basically, they shut it off as fast as possible, but it's not a perfect world. You can't just turn current off in an inductor. So there's a time window that it actually has like a linear ramp, and then it has a free decay. And so they actually start time 0 when the current hits 0, meaning that there's no more primary field.
Okay, if we're inducing a magnetic field though, why don't we measure the primary?
You can 3 microseconds.
Uh-huh.
That's actually how long it takes for the current to shut off from on to off. And there's tables for all of that for each instrument. That's probably pretty close. It could be 2.7, it could be something else, it's hard to say. Okay, so now that we're in here, make sure that we're on TEM47.
Is it? I don't know how to tell.
So
I
the
just
arrow?
click OK.
So yeah, if you see the arrow, and when you hit OK on that one, it should just kick you out back to the main menu. There you go.
Okay.
And so now in station,
Station.
it's going to say what's this station, what's the next station. Leave
Uh-huh.
those the same every time.
Okay.
I might change that to 2, just because the other group was 1.
Yusuf, you gonna like send out an email with those or something?
You can put it on the.
It's-
Oh,
yeah, I'll just
go
put it
away.
on YouTube.
Go back.
No, it's all video.
Welcome to the joys of the ProTem.
It hates me.
It doesn't just hate you, it hates everybody.
Can I write that in the instruction manual?
If you feel it. But I do want to be cited.
Okay.
Yeah. It's not like this is a truly academic paper, but cite you.
So then, I'm grading you, man. So then on the component,
I do that at the end of all my labs.
See his component.
And acknowledgements.
so then here
Special
it's
thanks to the
asking what you want to
guidance I
record.
I'd like to thank my
Z,
mom.
X, Y,
Mom?
ZX,
That's right.
ZY,
Shout out.
XY, ZXY.
Uh-huh.
Because we're using a 3D coil, go ahead and select ZXY
3D
in
coil.
general. Yeah, let's do it. And then records per component, you can basically say how many times you want to do this for every component.
Uh-huh.
For the sake of time today, let's change that to 10. But generally, in practice, you'll want to use 20.
Okay.
And you're probably going to have to hit 0 again.
I'm really glad we did this.
But it.
yeah, it's cool.
Okay.
We get to hear him tell us all about it today.
Yeah, seriously.
Okay. So then, if you go back to adjust,
Is this clear?
Adjust.
There we go.
and set that to 30 hertz repetition rate, which is that.
Where are you?
So-
oh, okay. So
yeah.
it's on 30.
So here at the top it says what's a sync mode.
Mhm.
There's crystal sync and reference sync. You're going to use reference, which is the cable. If
Okay.
you actually have a crystal sync, which I think your 57 does, but your 47 does not, you can set it up to have a super accurate clock between the two. Where you still need a reference cable to initially sync the clocks, but once they're synced, you can travel around without having your reference cable plugged in.
That's cool.
So that's just like if you have like a quartz crystal like clock that you can plug into there, it'll actually be really accurate. or
Which your
something.
57 does.
Okay,
Yeah.
gotcha.
Okay, so right now, you can only set your transmitter current when you're at your base frequency for that system. So the base frequency for the 47 is 30 hertz,
30 hertz.
which you see the little arrow is pointing
Yes.
at 30. Okay, so you can plug this reference cable in now.
Doesn't matter which
Do we need to
direction
go
it
to the
goes.
transmitter now?
Yeah, and now it's time to go to the transmitter.
Is that in all the way?
I can't push it farther than
It doesn't need much connection.